All right, so this question does say by considering the reciprocals. So let's first find the reciprocals and have a look at what we've got. So I think that part is okay for everyone to do. So the reciprocal of this one, we would multiply by root 6 plus root 5 over root 6 plus root 5. So we're multiplying by 1, and clearly we would get root 6 plus root 5 over 6 minus 5, which is 1. So that's the reciprocal of that one, and the other one would be root 5 minus 2. We'd multiply by root 5 plus 2 on root 5 plus 2, and again on the top we'd get root 5 plus 2, and on the bottom we would get 5 minus 4, which is 1. So we're looking at these two, that's what we're considering in order to, this is what we are required to prove. So if we start with what we've got, we know that I've changed to, there we go. We know that root 5 plus root 6, start with that, has to be bigger than root 5 plus 2 since, I'll just write this, since root 6 is greater than root 4, clearly, and root 4 is equal to 2. So we can, sorry, that's terrible writing. So we can start with this. This is something we definitely know, so let's start with that. And then we could look at, since we know that, we know when we find, and they're both positive, we know when we do the reciprocals of positives, as long as they're positive, when we do that, the reciprocals, we can change the inequality. So we can say that. Now that's getting us much closer. So now what we can do is use, again, is rationalize, realize our denominator. Oh, goodness. So let's go back. So now we can go kind of backwards to this and to this. Root 5. Actually, let me do it the other way. Sorry. So let's multiply by root 6 minus root 5 on root 6 minus root 5. There we go. So we will get, so we'll just swap those two, and you can get, on the denominator you would get 6 minus 5, which is 1, and on the numerator you would have root 6 minus root 5. And here on the denominator you've got 5 minus 4, which is 1, and on the numerator you have root 5 minus 2. So then we've proved what we want to prove.